So for example 5, this covers the summary of all of our binomials that are special to be factored. So difference of squared, difference of cubes, sum of cubes. The one that's not here is sum of squares, because sum of squares is not factorable. It is prime over the real numbers, so there is no way to factor sum of squares further. However, these three can be factored further into these forms, and these forms must be committed to memory in order to do well with these types of problems. So we are going to see a few of these with these examples here. So example 5a is m cubed minus 1/8. That m cubed is a dead giveaway that we're dealing with perfect cube, and because it's a minus sign, then it's going to be a difference of cubes. So we have to verify that the first term, the cube root of m cubed, is in fact the perfect cube, gives us m, and the cube root of 1/8 is also a perfect cube. The cube root would be 1/2. So now that we have our a and our b value for difference of cubes, it is going to follow the form of a minus b times for the first factor, in parentheses, the second factor, a squared, opposite sign, plus sign, ab, always positive, plus sign, b squared. So we are writing, we are going to be replacing m where we see an a and 1/2 where we see a b. So this turns into m minus 1/2 for the first factor times, in parentheses, m squared, opposite sign, plus sign, parentheses m, parentheses 1/2, and followed by always positive plus sign, and our b value of 1/2 in parentheses squared. So the first factor, nothing else that can be done with that, but our second factor needs to be simplified to get rid of these parentheses. So this turns into m minus 1/2 times m in parentheses squared is m squared, opposite sign plus sign, m times 1/2 is written as 1/2 times m, and plus 1/2 to the second power, which is 1/2 times 1/2, gives us 1/4, and that is going to be our answer for example 5a.